Thank you, SSI, Verenavis, and NDAR for this great event. A bit about me. My name is João. You are all forgiven for misspelling the name. It's a Portuguese name. I started my career here in Verenavis, and a few years fast forward, now I work at Royal Huisman. I'm happy today to show you how to use, one of the ways that you use MarineDrafting at Royal Huisman. Next one. Yeah, this is one. Well, much has been said about migrating 2D to 3D in shipbuilding. I still think that the truth is somewhere in the middle, and we will always make use of both approaches. Dennis has written many things and very interesting things about this topic, so I will not evolve about this. My goal here is just to show you how we make use of these two realities in, these two realities to coexist. I will guide you a bit through the process, how we arrived to this system, and part of the history behind it, and hopefully you can relate and perhaps get a little bit inspired. I'll try to be quick and try not to be so boring or to make things interesting. Well, we make use of a single source of truth. Everybody navigates the model. This model, it's no novelty to anyone. Everyone knows the concept is a proven concept, is very reliable, and a very efficient way of working. At Huisman, we feed this model with 5 submodels. But still the question relies. I need 2D information for my drawings. How do we get this done? Before we get to that, I will try to show you a little bit which are the sources that feed that model. I call them submodels, but they can be called anything else. We have the model line, which is a theoretical surface model, all the equipment parts, which are made in Inventor, the net spaces, which is, it's how do we account with the useful space inside of our projects in our ships. These two come from ShipConstructor, is the structure and all the systems and piping. The idea behind this is very simple. We have 5 sources, and we want them to be compiled in one single drawing. So there is a list of frames that we need, longitudinals, buttocks, waterlines, and this is the concept it was already existed at our Huisman when I get there, but it was a little bit old-fashioned. So the principle is formalized on this scheme, and this is one example that we could use frame 25 to be X-ref on this drawing, and this source comes in X-ref on this drawing, and this one, and this one, and this one, and this one. And it's quite a simple concept. To my opinion, it's very, very neat. How do we do this? Well, in the beginning, the naming of these drawings, and to respect the already history of the company and the sources and the origins behind it and the reason behind it, to match this, to systematize it, was quite a little bit of a challenge, to find a naming convention that suited all these automatization processes. But we find one, and you can see it here. This is an example for frame 25, and if you are wondering how frame 25 for this example would look like, then the end result would be something like this. Now, everybody across the shipyard can use frame 25 lively update, but I'll get to that as well. And, just play it. This is on your drawing. You can use it, and tomorrow, if there's a change on structure, you'll be able to see it. And still, you can compose your 2D drawing. We have what I call one common point of reference. So knowing that all the locations of the files are known, and they don't change, and all these models they don't exist on several versions. There's only one model for the model line, and there's only one model for the net spaces and so on. We know these locations. So we tracked everything in one Excel file. Everything is mapped out here, and the locations, frames, longitudinals, and waterlines, they are listed here. I can, at any time, if an engineer asks me, well, can I get frame 25 plus 355 millimeters? Yes, I will add it to the list, create the files. This will be automatically on the file next day for the, that frame will be on the list. How do we do this? We have a certain set of scripts and batch operations that we designed for this to be fully autonomous. We have batch operations that trigger PublisherLT, like Nick just showed you a while ago. These three operations run. We have to update the output drawings that feed these marine draftings, the ones to export the structure and the one to export the systems. And then we have a certain set of scripts because the source of the other files is Rhino. They just triggered. And you can see this can be run in a day. We have these ones are the heavy ones, and they can take quite some time, as you will see in a while. Rhinoceros for model line or theoretical surfaces runs in 6 minutes. The decking equipment, which is a heavy file, runs a little bit less than 2 hours. And the other one runs in 7 minutes. At the end, we run a final script that compiles this into a single file, which is can be extracted in any drawing from anyone across the shipyard. No need for license of marine drafting. We make use of marine drafting and we find a way to give it to everyone. And at the end of this process, we issue a notification for CAD managers, for project engineers, for myself. I have my box full of almost spamming emails with this notification that this was updated every day around 6 in the morning. So it's a good wake-up call. How does it look in marine drafting? So we have for structure, we have a single output file for the whole structure. So it's one output file for one project. And this was quite an achievement because it's a lot of parts. And from the structure, we have this sequence of frames, longitudinals, water lines, so on and so forth, and the same for systems. Okay, here you can see how does it look, the PublisherLT operations and what we do. So we have the output drawings, we update the drawings, and then from every frame, from every file, every single file, we update that view and we export it. I will show you a little bit how it looks on the other models. I ask someone to click here, please. This one is. Can you click it? Yeah. No. Ah. Sorry about this. I saw the mouse there, so it must be there. Yeah, it's running. So, yeah, as you can see, it's a batch operation which it runs fully autonomously, so the only thing, it reads the information from the Excel file where all the locations are mapped. Whoops. It's okay, it's okay. He's processing the frames, and yeah, I cut the video a little bit but this normally takes about 6 minutes for the whole process, and here is a little bit more than a minute. And this is, I don't know how are we in time, if I have time to show the other two. It is not so long, but 4 minutes. Let's skip it because the other one is exactly the same for a different model. And it's okay. And yeah, so for this project, we have about 500 files, 500 including frames, longitudinals, and waterlines. And if you are wondering how does this look like in a kind of 2.5D model, if we place all these frames back to their position, it looks something like this. So everybody can use frames, and you don't need to go to your ShipConstructor guy and say, hey, can you extract me that section on that location? And then you have to stop what you're doing because that guy doesn't have a ShipConstructor license. Now you just need to go to this folder, and this is updated daily. So, to conclude, well, we streamline 2D information across the company. Non-ShipConstructor users benefit from daily updates of 2D cross-sections on 3 axes. This is set once for project, and it's used throughout the project, and it's added if you need a frame that you didn't count initially. You can always add it, or a longitudinal. And at this time, we are actually including a way to make this diagonal or non-parallel to the UCS, so something like arbitrary. That is still being, on my head, being developed. Well, tools required for this, nothing out of the box, just AutoCAD, ShipConstructor, PublisherLT, Windows Task Schedule, a little bit of VBA for AutoCAD, VBScript for Rhino, which is free. It comes in Windows. Excel is quite useful because it's also VBA programmable. And at the end, we have an automatic email notification, as I explained earlier on. Achievements. We can have an update of output drawings of complete ship, either structure or systems. And that is quite remarkable because it can be a lot of parts. There was some things with some issues with updating a lot of frames that are heavy, with having one XREF that is quite heavy, then exporting this through Publisher turned out to be a little bit cumbersome, but we solved it. And now we have a 2-model output time plus all the other frames. This can run in 5 hours. We can also, we find a way to systematic treat MarineDrafting entities through the backdoor, in a way, through AutoCAD VBA. And there's a minimal number of manual operations. Just relink to files to database and a little bit update the task list every time there is a change on the operations, or we need to add a file or remove a file that is no longer needed. I think that we'll leave the questions for the end. Thank you very much.